It is very hard for archaeologists to explain how that was done using purely leverage and mechanical advantage.
Hidden deep within the Great Pyramid are massive granite blocks, crafted with astonishing precision, so precise that many believe such workmanship shouldn't have been achievable over 4,000 years ago. The traditional explanation claims ancient builders shaped them using soft copper tools combined with abrasive sand. Yet granite ranks among the toughest natural stones on Earth, and the tool marks preserved on its surface tell a very different story from the one found in history books. Before we uncover this incredible mystery, make sure to subscribe to the channel and turn on notifications so you never miss our latest explorations into ancient history, lost civilizations, and the world's greatest unsolved mysteries. Graham Hancock traced these mysterious marks through ancient quarries, forgotten tombs, and sealed chambers. Everywhere he looked, the same puzzling evidence appeared. But the people, or perhaps the technology, that created those marks vanished without leaving any clear trace behind. A stone that refuses to yield granite is incredibly hard. On the Mohs hardness scale, it measures around 6 to 7, while diamond, the hardest natural material, sits at 10. The principle is straightforward. To cut a material efficiently, your cutting tool must be harder than the material itself. That creates an obvious problem. Trying to shape granite with soft copper is like attempting to carve solid rock using a wooden spoon. The tool would wear away long before the stone showed any meaningful sign of damage. So how did a civilization, equipped primarily with copper tools, manage to carve, hollow, and polish thousands of tons of granite with such extraordinary accuracy? Even more astonishing, how did they achieve finishes that remain difficult to duplicate with today's advanced machinery? That question lies at the center of the mystery, and it's exactly where the accepted explanation begins to fall apart. The experiment that raised more questions. Eventually, researchers decided to test the ancient method themselves. Using copper tools and sand, they attempted to drill into solid granite exactly as the traditional theory describes. If the textbooks were correct, the experiment should have confirmed it. Instead, the results told a different story. After 20 hours of non-stop effort, the team managed to penetrate only about 6 centimeters before the copper tool was completely worn out. One researcher later summed up the entire experience with a single word: comical. Now compare those results with what ancient Egypt supposedly accomplished using the very same technique. Monolithic obelisks weighing hundreds of tons, granite boxes polished to near-perfect flatness, more than 40,000 stone vessels, many with walls as thin as an eggshell. It's difficult to reconcile those achievements with a method that struggles to drill just a few centimeters into granite over an entire day. Graham Hancock focused on that enormous contradiction, the vast gap between what modern experiments demonstrate and what conventional history claims. To him, that gap suggested the possibility that an important chapter of human history may still be missing. The surveyor who changed everything. To understand Hancock's argument, we have to travel back to Egypt in 1883. An English archaeologist named William Flinders Petrie arrived carrying measuring tapes, calipers, and precision instruments instead of chasing treasure like so many others. While many excavators searched for gold, jewels, and royal burials, Petrie was interested in something far less glamorous, but far more revealing: accurate measurements. That attention to detail led him to notice evidence everyone else had overlooked. Among scattered debris left behind by ancient stoneworkers, Petrie found several discarded drill cores, The cylindrical pieces of stone left inside drilled holes. Most people would have dismissed them as worthless rubble. Petrie did not. When he carefully examined their surfaces, he discovered perfectly formed spiral grooves wrapping around each core like the threads of a screw. They were smooth, evenly spaced, and remarkably consistent. After measuring the depth and spacing of those grooves, Petrie reached a startling conclusion. The drill that produced them appeared to have advanced through solid granite at a rate that seemed astonishing, far faster than anyone believed possible with the tools ancient Egyptians were supposed to possess. It was the first truly compelling physical clue, and it pointed toward a possibility that challenged everything historians thought they knew. A conclusion that has left careful researchers questioning the accepted story ever since. More precise than modern equipment? This was the discovery that completely changed Petrie's perspective, and it continues to puzzle engineers even today. After carefully studying the drill cores, Petrie calculated how much granite had been removed with every rotation of the drill. The numbers were astonishing. According to his measurements, the cutting speed appeared to exceed what many modern diamond-tipped drilling systems can achieve when working through granite. If those calculations are correct, the implications are extraordinary. Producing cuts like that would require an immense amount of constant downward pressure. Petrie estimated that the drill would have needed well over 2 tons of force, applied evenly throughout every single revolution. The pressure couldn't fluctuate. It couldn't crack the granite, damage the tool, or drift off course. He simply couldn't explain how ancient workers using hand-operated tools could have maintained that level of precision and force. Then there was another clue, one that may be even harder to ignore. Anyone who drills by hand naturally introduces tiny inconsistencies. Muscles tire, hands shift, and the angle changes ever so slightly. Those small movements always leave irregular marks behind. But that's not what Petrie found. The spiral grooves wrapped around the drill cores with remarkable consistency. Every turn followed the last with the same depth, identical spacing, and an uninterrupted spiral from beginning to end. Those aren't the random marks of human fatigue. They resemble the signature of a system operating with unwavering mechanical precision. And those mysterious drill cores were only the beginning. The 40,000 stone vessels that defy expectations today, museums across the world house more than 40,000 ancient Egyptian stone vessels. Many date back over 5,000 years, older than the pyramids themselves, from an era traditionally believed to have possessed only the most basic tools. Yet these artifacts seem far beyond what those tools should have produced. Many were carved from granite, quartz, and diorite, materials among the hardest known natural stones. Some have walls only a few millimeters thick, so uniform that light can pass through portions of them. Their interiors were hollowed through openings so narrow that ordinary hand tools could barely reach inside, let alone carve with such precision. Even more remarkable, the surfaces appear polished almost like glass, with virtually no visible tool marks remaining. When modern scanning technology analyzed these vessels, the measurements surprised even experienced engineers. The two sides of a single vase aligned with each other to within roughly the width of a human hair. One detailed examination measured dimensional variation at less than 15 microns. To put that into perspective, that's a level of precision comparable to, or in some cases finer than, what modern manufacturing routinely achieves using advanced machinery. One highly skilled craftswoman attempted to reproduce just one of these vessels using only the kinds of tools traditionally attributed to ancient Egyptians. She devoted nearly 2 years to the project. Despite her experience and patience, the finished piece lacked the symmetry, smoothness, and accuracy of the original. Her conclusion was refreshingly honest. Recreating these objects entirely by hand was, for all practical purposes, impossible. That naturally raises an uncomfortable question. If simple tools cannot reproduce these objects today, what kind of technology or technique was originally used to create them? One engineer decided to investigate that question himself. The engineer who looked at Egypt differently. Archaeologists are experts at studying ancient cultures through artifacts, inscriptions, and human remains. But interpreting manufacturing techniques requires a different kind of expertise. Christopher Dunn brought exactly that. For more than 50 years, Dunn worked in precision engineering, producing components for jet engines, an industry where microscopic errors can lead to catastrophic failures. Beginning as an apprentice machinist in Manchester, England, he eventually became responsible for tooling, production, and quality control for aerospace components built to extremely demanding tolerances. His career revolved around precision machining, measurement systems, grinding equipment, and advanced manufacturing methods. Few people understood the realities of producing perfectly machined surfaces better than he did. When Dunn began examining ancient Egyptian stonework, he noticed details that many others had overlooked. Over the course of 3 decades, he traveled to Egypt 9 different times, not as a sightseer, but as an engineer, conducting careful inspections. He carried precision straight edges, measuring instruments, and decades of practical experience, evaluating machined surfaces. One of his most significant investigations took him beneath Saqqara, where enormous granite boxes rest inside underground tunnels. Each box weighs roughly as much as a small house. Standing inside those chambers, Dunn placed his precision tools directly against the granite walls, determined to measure the surfaces for himself rather than relying on assumptions. What Dunn discovered challenged everything he expected to find in an ancient civilization. The interior walls of the massive granite boxes were astonishingly precise, measuring flat within roughly 0.02 of an inch. Even with today's advanced equipment, producing granite surfaces to that level of accuracy remains a demanding task. Every corner formed a perfect right angle, and the opposing walls ran almost flawlessly parallel from end to end. To Dunn, this didn't resemble the gradual work of craftsmen, patiently shaping stone with chisels. It looked like precision engineering. Later, he remarked that the tolerances found in Egyptian stonework surpassed what modern industry often requires today. He wasn't exaggerating for dramatic effect. He was describing what his measurements revealed, what engineers kept discovering. Dunn wasn't the only engineer to leave Egypt with difficult questions. As more machinists, toolmakers, and manufacturing specialists examined the monuments firsthand, many independently noticed the same unusual features. Across granite blocks, they observed long, uninterrupted cutting lines that looked remarkably similar to the tracks left by powered machinery rather than the uneven scars produced by repeated hammer and chisel strikes. They inspected drilled holes whose inner walls appeared smooth and polished, maintaining nearly identical diameters from top to bottom. Instead of irregular hand tool marks, the surfaces displayed the kind of consistency normally associated with controlled mechanical cutting. At Luxor, engineers studying colossal statues measured the faces and found an extraordinary degree of symmetry. The left and right halves aligned with remarkable precision, accuracy that is incredibly difficult to achieve by eye alone, but far more achievable through careful measurement and controlled manufacturing. These observations didn't come from fortune hunters or storytellers. They came from professionals whose careers revolve around machining metals to extremely tight tolerances. Standing before monuments thousands of years old, many felt they were looking at manufacturing signatures surprisingly familiar from their own industries. Again and again, they reached a similar conclusion. Traditional explanations, relying solely on copper chisels, pounding stones, and sand abrasives, did not appear sufficient to account for every feature they observed. The workmanship seemed too consistent. The tolerances appeared too precise, and the sheer number of finely crafted objects made the mystery even harder to ignore. Whether the answer involved forgotten techniques, lost technologies, or methods no longer understood, many believed something important remained unexplained. The question was no longer whether gaps existed in the traditional narrative. It became how significant those gaps might actually be. The timeline that doesn't follow expectations. One detail makes the puzzle even more intriguing. Normally, civilizations improve over time. Skills develop through experience. Each generation builds on the knowledge of those before it, gradually producing more advanced structures and finer craftsmanship. Following that pattern, Egypt's earliest monuments should be the simplest, while later generations should display the highest levels of achievement. But the archaeological record appears more complicated. The Great Pyramid at Giza stands among Egypt's earliest monumental constructions. At the same time, it is widely regarded as one of the country's most ambitious engineering accomplishments, remarkable for its scale, precision, and complexity. Many later pyramids are noticeably smaller, less refined, and in several cases have suffered greater structural deterioration. It's an observation worth thinking about. If architectural knowledge steadily advanced through continuous improvement, why do some of the earliest monumental projects appear to represent the highest standards of precision? Instead of a clear upward progression, the pattern seems less straightforward. Learning typically follows an upward curve. Here, at least in some respects, the curve appears to move in the opposite direction. One possible interpretation is that later builders were preserving techniques inherited from earlier generations, rather than continuously improving upon them. That possibility raises an even larger question. Where did the original knowledge come from? It's a question Graham Hancock has spent decades exploring across ancient sites around the world, and his proposed answer remains one of the most controversial ideas in archaeology: a civilization before recorded history. This is where Hancock presents his most debated hypothesis. Importantly, he does not claim to know exactly what tools were used, nor does he argue that physical machines from that era still exist. He openly acknowledges that if advanced technology once existed, it has long since disappeared, and any written instructions would almost certainly have been lost over thousands of years. Instead, he focuses on the physical evidence that remains. According to Hancock, the marks preserved in stone deserve to be examined without assumptions. He argues that those marks suggest a level of capability that may not fit comfortably within the conventional historical timeline. From that perspective, he proposes that the ancient Egyptians may not have developed these techniques entirely on their own. Rather, they may have inherited knowledge from an earlier culture. Hancock suggests that before the rise of the pharaohs, and perhaps even before the beginning of recorded history, an advanced civilization may already have existed. He believes that civilization could have been destroyed roughly 12,000 years ago as the last ice age came to an end. Geological evidence confirms that enormous ice sheets melted during this period, triggering dramatic rises in sea level and widespread flooding across many coastal regions. Since human settlements have often been established near coastlines, Hancock argues that any advanced coastal civilization from that era could have been heavily affected or even erased from the archaeological record. In his view, the survivors may have carried fragments of their knowledge to distant regions, influencing later civilizations in places such as Egypt, Turkey, and South America. Whether that hypothesis ultimately proves correct remains the subject of ongoing debate, but the precision carved into ancient stone continues to inspire one enduring question. Could history still be missing an earlier chapter that has yet to be fully uncovered? According to Hancock, the people who settled in Egypt may have inherited fragments of knowledge from survivors of a much older civilization. If that's true, then the extraordinary precision seen in Egypt's granite monuments wasn't originally invented by the Egyptians. It was passed down to them. A legacy. Knowledge preserved only in pieces. Over generations, the techniques may have been copied without being fully understood, until the original mastery slowly faded from memory. This idea also offers Hancock's explanation for one of archaeology's most puzzling patterns. Egypt's oldest monuments often display the highest level of precision, while many later structures appear less refined. Graham Hancock argues this suggests the Egyptians inherited advanced knowledge rather than developed it over time. Most archaeologists reject this idea, but the debate continues because of the physical evidence. Hancock points to the granite drill cores, thousands of precision-cut stone vessels, and the Great Pyramid itself. These artifacts can still be measured and studied today, and many engineers believe their accuracy raises important questions about ancient construction methods. Whether the Egyptians mastered forgotten techniques or inherited knowledge from an earlier civilization remains unproven. But one mystery endures. Who really taught the ancient Egyptians to shape granite with such incredible precision? Let us know what you think in the comments below.